1905 Mirabilis papers. The Annus Mirabilis papers are 4 articles pertaining to the photoelectric effect, which gave rise to quantum theory, Brownian motion, the special theory of relativity, and E=mc2 that Einstein published in the Annalen der Physik Scientific Journal in 1905. These 4 works contributed substantially to the foundation of modern physics and changed views on space, time, and matter. Theory of critical opalescence. Einstein returned to the problem of thermodynamic fluctuations, giving a treatment of the density variations in a fluid at its critical point. Ordinarily, the density fluctuations are controlled by the second derivative of the free energy with respect to the density. At the critical point, this derivative is zero, leading to large fluctuations. The effect of density fluctuations is that light of all wavelengths is scattered, making the fluid look milky white. Einstein relates this to Rayleigh scattering, which is what happens when the fluctuation size is much smaller than the wavelength, and which explains why the sky is blue. Einstein quantitatively derived critical opalescence from a treatment of density fluctuations, and demonstrated how both the effect and Rayleigh scattering originate from the atomistic constitution of matter. Special relativity. Einstein's Zur Elektrodynamik bewegter Körper, on the electrodynamics of moving bodies, was received on 30 June 1905 and published 26 September of that same year. It reconciled conflicts between Maxwell's equations, the laws of electricity and magnetism, and the laws of Newtonian mechanics by introducing changes to the laws of mechanics. Observationally, the effects of these changes are most apparent at high speeds, where objects are moving at speeds close to the speed of light. The theory developed in this paper later became known as Einstein's special theory of relativity. There is evidence from Einstein's writings that he collaborated with his first wife, Mileva Marić, on this work. The decision to publish only under his name seems to have been mutual, but the exact reason is unknown. This paper predicted that, when measured in the frame of a relatively moving observer, a clock carried by a moving body would appear to slow down, and the body itself would contract in its direction of motion. This paper also argued that the idea of a luminiferous ether, one of the leading theoretical entities in physics at the time, was superfluous. In his paper on mass-energy equivalence, Einstein produced E=mc2 as a consequence of his special relativity equations. Einstein's 1905 work on relativity remained controversial for many years, but was accepted by leading physicists, starting with Max Planck. Einstein originally framed special relativity in terms of kinematics, the study of moving bodies. In 1908, Hermann Minkowski reinterpreted special relativity in geometric terms as a theory of spacetime. Einstein adopted Minkowski's formalism in his 1915 general theory of relativity.